Hi everyone. In this video, we're going to be putting the pieces of demand and supply together into a working model to help us uh, achieve our goal that we started off with way up here, to understand how a free and competitive market determines the prices of products and the quantity sold, right? So that was our originally stated purpose, and that is still our goal. So there are a few different ways we can put the pieces together, demand and supply together, and analyze how things should work. But I think it'll probably be most useful if we start off with the simplest version, which I think is going to be the table. So here is a table of, let me see if I can make this a little bit bigger. Uh, how do, is it like this? No. Okay. I think if I go to home and make the text here bigger, maybe that works. Yeah, okay, there we go. So here, this is the same information from the table that I outlined from before in the previous video here. I'm just copying and pasting it from like my own personal notes to kind of like make it look a little bit neater. So, um, that's why it looks like text rather than, my handwritten type thing that you saw from the last video. Okay, so this is the same information, right? Bags of chips that a store sells or wants to sell over the course of a week at various prices, and how many bags of chips the customers will want to buy at various prices. So let's analyze what should happen in this market. Remember, our goal is to try and understand what the price of this item will be, what the price of a bag of chips will be, and how many bags of chips will end up being sold. So, first, I will just go ahead and say that this here is what is known as the equilibrium where the equilibrium price, as we can see in this row, equilibrium price and equilibrium quantity. And these are the prices and the quantity that the bag of chips will be sold at, and the number that will be sold. That is, if this is a free and competitive market, the amount of bags of chips that will end up being sold is 210, as given by the quantity demanded and quantity supplied here, where the numbers are both 210, and the price that they will be sold at is at $3. Okay, so that's what I assert, right? That's my assertion. But now, how do I support that assertion? Well, like, how do I figure like that's what's actually going to happen, right? That um, the price will be the equilibrium quantity of $3, and the amount that will be sold will be 210, the equilibrium quantity, right? So I I want us to think about, well, what if the price ended up being something other than $3? Let's say that the price was, say, $4 instead of $3, right? Well, if the price was $4, right, then what will happen is that, as we can see, uh, 180 customers will want to buy a bag of chips this week. And the store will want to have sold 280 at this price. So we can think of this as like, say, the store gets 280 bags from its supplier. Um, so it purchased 280 bags of chips, expecting and wanting to sell all 280 at the price of $4 per bag. But as we can see, that doesn't really work out, right? Because if only 180 customers want to buy a bag of chips, then of course that uh, they only manage to buy 180, right? So they have an extra 100 bags of chips left over. So if the price was, say, $4, there will be an excess supply of the 280. This is the quantity supplied minus the 180 quantity demanded. So that ends up being 280 minus 180, 100 bags of chips of excess supply. So basically, that means at the end of the week, there'll be an extra 100 bags of chips that the store has lying around. And of course, the store isn't going to be very happy about that, right? Because they purchased 280 bags of chips from the dealer. So that's how much that they bought, thinking that they should be able to sell 280. But as it turns out, they only managed to sell 180. And that just means that the store just wasted money, right? Because they bought an extra 100 bags of chips that they didn't manage to sell. So they're just like sitting on store shelves, right? Such that there's some money left on the table since they spent all the extra money on bags of chips that they didn't manage to sell. So the store's not going to be very happy about that. And this is going to be true, as we can see, if the price was also $5, right? If the price went up to $5 per bag of chips, then the quantity demand is 150, quantity supplied is 350, so the excess supply will be 200 bags of chips instead of just 100. And then if the price went up to $6, then quantity demanded is 120, quantity supplied 420, which means that there will be an excess supply of 300 bags of chips. So that means that if they try to increase the price, right, the excess supply is only going to get bigger and bigger, which again, hopefully that makes a lot of sense because, well, as you raise the price, then consumers will, of course, not want to buy as much compared to before. So the excess supply just keeps getting bigger and bigger. So the wasted money just becomes bigger and bigger as well because the store, sees fewer and fewer sales as they keep buying more and more bags of chips from the dealers. So in order to get rid of this excess supply then, what they will want to do is lower the price instead. Because as we can see, if they lower the price from $4 to $3, then there's no longer an excess supply. The amount that consumers want to buy is 210, and the amount that the store bought from the dealers is also 210. So since those two numbers match up, they have just as many bags of chips that they managed to sell to the customers, which means that they didn't waste any money, which is of course good, right? Because again, the store is trying to make a profit, so of course it doesn't want to waste money either. So anytime the price is above $3, which we labeled our equilibrium price, that means that the store has an incentive to lower the price. There's a pressure to lower the price in order to get rid of the excess supply, in order to increase their sales. Because if the price was above $3, then they have an excess supply, meaning that, they have extra goods left over that they haven't managed to sell, which means that they've wasted some amount of money, right? Because they spent money buying this extra stuff that they didn't manage to then sell to the customers. So that's why the price should not be higher than $3, right? Hopefully, I've made a pretty good convincing case for why that will be, or why that is, why it shouldn't be higher than $3. What about the opposite? What if the price was less than $3? Let's say at $2. So let's scroll down here a little bit. So if price was $2, what will happen? Well, if the price was $2, then customers will want to buy 240 bags of chips, as we can see from here. But unfortunately, the store doesn't find it to be especially profitable to be selling their bags of chips at only $2 per bag, right? Because that's not going to be netting them much of a profit margin. So they will only buy 140 bags of chips from the dealers. They would rather spend any other money on perhaps other types of groceries, other types of snacks, maybe that that the store expects that they can make a high profit margin on, which is why they, if they are selling each bag of chips at only $2, they will only invest in purchasing 140 of them from their dealers. Right? So despite the fact that customers want to buy 240 bags of chips this week, well, there are only 140 to be sold at the store. So that means, of course, well, what's the actual amount that will be sold? Only 140, right? Because there's only that many that exists to be sold. So even though customers want to buy 240, because there are only 140 bags of chips to be sold in the first place, that means that there are only 140 sales. So this case is what is called excess demand. So before there was excess supply, right? When quantity supplied was bigger than quantity demanded, right? Like in this case, when the price was $4, stores bought 280 bags of chips from the dealers, but customers only bought 180 of those bags from the store, which of course hopefully makes sense because you can't force customers to buy more than what they want to. So only 180 bags ends up being sold, and there ends up being an excess supply of 100 because there are 100 bags left over sitting on store shelves. Here there is the opposite situation. Here there is an excess demand of, and let's just check those numbers again to make sure I got them right. At $2, there is 240 bags that customers want to buy and 140 bags actually available to buy. So 240, and this is QD here, minus 140. That is QS, quantity supplied. So there are 100 bags of chips of excess demand when the price is $2. Now, in this case, the store will notice that there's still quite a bit of demand for bags of chips, but they've already sold out, right? So in this case, it might be like customers coming to ask an employee at the store saying like, "Oh, I want to buy a bag of chips. Where are they?" And then they're sold out, right? So then the store will notice that, oh, so there are still people who want to buy bags of chips, but we've already sold out. So what can the store do to resolve this situation, right? Well, they could lower the price, but will that help that situation out? Let's check. If a store lowered the price to $1, well, then quantity demand becomes 270, which, bigger than before, which makes sense because the law of demand, right? Lower price means people want to buy more of a product. But when the price is so low, then the store doesn't see much of a profit margin, so they don't invest in that many bags of chips. They would rather, again, invest in other products that they can sell in order to make a bigger profit margin. So here, they only want to buy 70 bags of chips. So the excess demand actually gets bigger when they lower the price from 100 excess demand to 200 now, right? 270 minus 70. Same thing if the price went down to 0, which of course, at that point the store wouldn't want to sell any because that just means that they'd be giving away the bags of chips for free, which, that's not typically how you earn a profit while running a business. So, what about the opposite? What if the store instead raises the price, let's say from $2 to $3? Well, now we're back at this situation where customers want to buy 210 and the store has 210 to sell. So there's no excess demand in this case, and there's no excess supply in this case either. So here, there is an incentive for stores to raise the price when there is an excess demand, when the price is below $3. So that is why this equilibrium price of $3 and the equilibrium quantity of 210 bags of chips is what the price will actually be for bags of chips, and what the amount of chips will actually be sold, right? It should be $3 per bag of chips and 210 sales at the store each week, right? That's why it should be $3 and 210. Now, we know that because it should be the case that the quantity demanded should be the same as the quantity supplied. If the quantity demanded is bigger than quantity supplied, then there will be excess demand, like what we saw when the price was $2. And so there will be pressure for stores to increase the price to try and meet that high level of demand for the product, right? They don't want to have that shortage type situation going on there. And if the supply is bigger than demand, quantity supplied is bigger than demand, then there's an excess supply where the store wasted some amount of money buying extra products that they didn't end up being able to sell to their customers. So they want to lower the price. It's only when quantity demanded is equal to quantity supplied that there's no longer pressure for the store to change the price. That is why it should be here at price of $3, where quantity demand is 210 and quantity supplied is also 210. That is also why it's called the equilibrium. The equilibrium is just a term that means that there is like no, it's a state in which nothing should change, right? So at the price of $3, we're at equilibrium because there's no incentive for the store to try and raise or lower the price. If the price was higher than $3, then there would be an incentive for stores to lower the price. If the price was $2, then there would be an incentive for the store to raise the price. But at this equilibrium price of $3, there is no longer an incentive for stores to change the price because quantity demanded is exactly equal to quantity supplied. So, just to make sure all that is clear, where QS equals QD is the equilibrium. This is the price that the goods will be sold at and the quantity of goods that are sold, that will be sold. And again, this is assuming a free and competitive market. As we will see in later chapters, if it is not a free and competitive market, then it might not necessarily work out this way. So that's how we can put demand and supply together on a table, just like this. But remember, we also learned about demand and supply using a graph and using equations. So let's go ahead and take a look at how that works as well. Here, I am going to just copy and paste from my notes a graph. This is the same graph that we did from before, but it's just like made to look a little bit neater because, you know, I made this in Excel. But this is, you know, using the same data that we used from before. So it's using, you know, these prices and quantities found in this table here. That's how I plotted this out. Then, what does the equilibrium look like? Well, the equilibrium then would just be right here. That is the equilibrium. And we know that because that is where quantity demanded equals quantity supplied, right? Quantity supplied here is in the orange line, quantity demanded is in the blue line. So where demand crosses supply, that is our equilibrium, right? Where those two quantities are equal to each other, just like what we saw in our table, where quantity demanded is 210 and quantity supplied is also 210. So when we see a demand and supply graph like this, just where the supply curve crosses the demand curve, that becomes our equilibrium. And the quantity here, which is, in this case, it's 210. It's not like labeled because the way that the axes are set up. But I can go ahead and like mark that down here. That's going to be 210. And the price here is at $3. That's our equilibrium price. Okay, now what if the price was something other than $3, right? Well, let's go ahead and clean this up just a little bit. There we go. Okay. So let's say what if the price was $4? We can analyze this situation as well on the graph. We just have to take a look at where the $4 is. Here, now we're crossing the blue line for the demand curve. So let's draw a dashed line down here. Now it's not labeled here, but as we know from our table, at the price of $4, that's going to be a quantity demanded of 180. So I'll go ahead and mark that here. And keep going across until we hit the supply curve from the price of $4. And we know that this here is a quantity supplied of 280. Right? So then the excess supply is just the difference between these two. Excess supply equals 280 minus 180 equals 100, right? The 280 coming from quantity supplied, that's this orange point right here. That's QS, and 180 here being the quantity demanded, right? That's the blue point right here. So that's how we analyze excess supply on the graph. What about excess demand? Well, let's clean this up a bit. There we go. What about excess demand? Let's say, what if the price was $2? Well, draw a dashed line across from $2. Here is a supply, right? That's in the orange. And that tells us that we have, let's see, 140 bags of chips being supplied here at a price of $2. And then keep going across until we hit demand. That's the blue point right here. And that's 240 bags of chips that customers want to buy. So excess demand is just represented by the difference between these two numbers instead. So excess demand, which is just the 240 minus 140, that's QD, that's QS, and that's 100 bags of chips, right? And just again, to make sure it's clear, we know this is excess demand because the demand is bigger than supply at this price, right? That's why it's called excess, right? But when the price was $4, that was excess supply because the supply number was bigger than the demand number, right? So yeah, that's how we analyze this on the graph. And that's how we know that this here will be the equilibrium, because if it's less than $3, if the price was less than $3, there would be excess demand, which puts pressure on the store to raise the price. And if the price was higher than $3, then there'll be pressure, there'll be excess supply, and there'll be pressure for the store to lower the price instead. Okay, so last but not least is analyzing supply and demand mathematically. So what I'll do is, just like before, I'll copy paste the equations from my own notes. Let's actually make this a little bit bigger so it's easier to read. There we go. So these are the same equations that we got from before in the previous videos. So here's our demand equation right here, the first one. And the second one is our supply equation. Just so you can confirm, I'll scroll back up real quick to show that. Here's our supply function, right? Which is the same as what we saw down there. And our demand function is right here, right? Which is the same as what you saw from down there as well. Okay, so how do we analyze this mathematically? How do we know what the equilibrium is when looking at just the math? Now, it's fortunately pretty simple, but it does require a bit of math, a bit of algebra. So we know by definition, right? By definition, that the equilibrium is where quantity supplied equals quantity demanded, right? That's what the equilibrium in demand and supply means. It's just where those two numbers, where those two quantities are equal. So we can set those equal to each other and solve for quantity. Right? So here we have prices equal to, some numbers here, and here we have prices equal to some more stuff over here. So we can actually just have these set equal to each other. So now we have minus 1 over 30 Q. Here I'll be denoting the equilibrium quantity as Q star. The star denotes that this is the equilibrium quantity, right? Plus 10 is equal to, here I'll just set that to the supply function here, which is 1 over 70 Q star. Right? since, you know, the demand function and the supply function are both written in the form of P is equal to, you know, some stuff, that means I can set them equal to each other here, right? So here I just need to do a bit of math to solve. Having a calculator here is fairly useful, but I already have it all kind of like worked out. So what ends up being is here I would just add plus 1 over 30 q star plus 1 over 30 q star, because we're just trying to solve for the q star, right? So we want to get off to one side of the equal sign, and what that ends up being is 1 over 21 q star is equal to 10. So then multiply both sides by 21 to solve for q star, and here we go. Now we get 210 for equilibrium quantity, which is exactly what we worked out from before as well, right? On the table and on the graph, we saw equilibrium quantity is 210. That's not the entire thing though, because we still need to work out the price. So let's substitute q star into our demand function, as well as our supply function. So now we have P star, that is the price, right? We're solving for the equilibrium price now. Actually, I just mark that down just to be clear. To solve for equilibrium price. So that means we have P star is equal to, this is our demand function, minus 1 over 30 times 210, right? Because this is the quantity, the equilibrium quantity that we got right here. And I'm just substituting that Q star is equal to 210 into right here, right? The quantity here is 210, so I just put that right into the demand function. Okay. And if I were to plug all that into my calculator, we'll see that is minus 7 plus 10, or 3, right? And there's our equilibrium price right there. Now, theoretically, we could stop right here, but a good way to double check your answer is to also substitute in q star is equal to 210 into your supply function as well, and see what number you get from there. So from the supply function, remember that's just 1 over 70 times the quantity, which we see from up here is 210. So we do that math, that also ends up being 3. Now, it gives us the same answer, so you might ask, well, what's the point of doing it twice then? Why can't I just choose the demand function or the supply function and then just doing the one calculation and then getting the price that way? Well, you can do that, but it's a much safer way to double check your answer if you do it both, if you substitute in the quantity into both the demand and the supply function. Because if you end up with the same answer for price, then that means you know for certain that your answer is correct, right? But if you end up with two different prices when you put in your quantity for the demand function and the supply function, if you end up with two different numbers here for price, that means you did something wrong. And so you know that can't be the right answer. You should go back and double check to see where things might have gone wrong. Whether you did the math wrong in either of these steps down here, or maybe you did the math wrong somewhere up here instead, right? So it's just a good way to double check your answer to make sure, yes, I know for certain this is the equilibrium price and equilibrium quantity. And again, we can also double check by comparing to our answers from before, right? Equilibrium price here is $3 as we see on our graph because that's where the supply curve crosses the demand curve. And it's also given in our table here because that's where the two quantities, the quantity demanded and quantity supplied, are the same. So we know for certain, this all works out. Okay, now to just kind of round out this little discussion here, let's just take a look at how we analyze excess demand and excess supply cases using just the math, just using the equations, right? So for example, if I was just given these equations and I was asked this question, if price is equal to, let's say, $5, is there excess supply or excess demand? And if so, how much is the excess? And we know from before, from looking at the graph and looking at the table, that of course there is going to be an excess supply. But let's just say if we were just given this question by itself, right? And we weren't given the table or anything or the graph, we were just given these equations, right? Then how do we find the answer to this question? Well, all we have to do is we're given a price, $5. So let's substitute that into our demand function and our supply function to find out, well, what's the quantity demanded at that price and what's the quantity supplied at that price. So we'll start with demand. So substitute P equals 5 into demand and solve for QD, and then substitute P equals 5 into supply and solve for QS, right? Because then we will know what the quantity demanded is and we'll know what the quantity supplied is. And then from there we can figure out if it's excess demand or excess supply. So we have 5 is equal to minus 1 over 30 QD plus 10. If we work out the math here, I'll just show you the short version. Our quantity demanded should end up being, oh, whoops. There we go. Misread a section from my notes. There we go. Quantity demanded should be 150 at the price of $5. Now with supply, 5 is equal to 1 over 70 QS. That means QS will be 350. Okay, so here since QS is greater than QD, there is an excess supply of the 350 quantity supplied minus the 150 quantity demanded, so 200 bags of chips. Okay. So that's how we analyze if there is excess supply or excess demand. We can do the same method if the question was asking like, what if the price was say $1, right? You do the same thing, except you substitute price is equal to 1 into the demand function and price is equal to 1 into the supply function. You work out the math, solve for QD, solve for QS, and then compare which one is bigger, QD or QS. And the bigger one tells us, there's an excess supply of that, right? Then you take the difference, and then you get the excess demand or supply. Right? So yeah, that will just about take care of it for this video. Next time, we'll be taking a look at some of the other factors that can affect demand and supply of products other than just the price. So I will see you then.